Okay, for our very last example, we've got a pirate walking 200 meters at 120 degrees, turning and walking 250 meters at 340 degrees to bury his treasure. Determine the resulting displacement. So once again, just like the last problem, anytime we have multiple directions that they're walking in the problem, or they're moving, we're going to split it up into its parts. So the pirate walking 200 meters at 120 degrees is part one. And then turning and walking 250 meters at 340 degrees is part two. So it would look something like this if I were to split it up. For part one, we've got the 120 degrees, right, on the Cartesian system. So if 0 is over here, this is 90, this is 180, 120, somewhere in between. And for section 2, he's gone 340 degrees. So he's basically gone all the way around, just 20 degrees from a full circle. If it's easier, you can split that up into some triangles. It's kind of own triangles here, where you've got, well, this is 30 degrees from that 90 degree angle there. So it's a bit easier to kind of wrap my head around. So I got 30 degrees from the north, kind of moving towards the west here. So what I have to do is find those XY components. So the Y component, the adjacent side, right, is cosine. And now we're getting a bit better with this. We can just write out the cosine of 30 times 200 meters. It's positive because this vector is drawn going up, going to the north. For the X, it's compared to this angle, it's the opposite side. So you've got sine of 30 times 200, and it's negative because it's going west, right? He's going in that northwest quadrant. I look at, for section 2 here, if I redraw my triangle, he's going kind of down into the southeast quadrant, 250 meters at 20 degrees. So if I were to split this up, I'd find my X and my Y. Once again, the X is cosine of 20. So we've got the adjacent side times the hypotenuse. It's going to the right, so we said that's positive for the east. This is going down towards the south. So we've got our negative sine of 20 times 250. Now that you've got all your components split, make a table for yourself, right? Where we've got our section 1, section 2, and our total. Split up the XY, and we're just translating that data into our table. So all we're doing now is taking the values we looked above and put all for the X's, all for my Y's. And then what I want to do is sum these. So I want to add these two together. So if I add negative sine 30 times 200 plus cosine of 20 times 250, I find 134.92 and a bunch of other digits. For our second one, for our Y, we're adding cosine of 30 times 200 plus negative sine of 20 times 250. I find I get 87.7. Those are my total vectors. This is the total vector in the X, total vector in the Y. Then I can look, I can go, okay, I've got my triangle, I can redraw it, I can draw either vector first. This time I chose to draw the X first. Draw the X, then draw the Y. You're finding that dotted resultant. So that's just a squared plus b squared equals c squared, which gives me about 161 meters. Then I'm finding the angle, which is just the tan of 87.7 over 134.9. And I can find, okay, this is 33 degrees in this first quadrant. So I don't even have to write north, south, east, or west. I go back to the question. And in the question, it was all 120 degrees, 340 degrees. It was that Cartesian system. So then my final answer is going to be in a Cartesian system as well. So my final answer is going to be 161 meters at 33.0 degrees.